Yes, the mic was off. All right. Different state, same shit, is what it is. Let's get her done. Let's go. You remember what I was doing? I think I was on the quiz, chapter 9. Yeah, we learned assert and static assert for compile time assertions, and then high and low. Okay. Make high-low to handle invalid guesses, extraneous input, and handle that for characters too. Nobody cares about the hint. Okay. I guess. Certain amount of guesses. We can set that. Loop. Might just have a while true. And then depending on the guess count, or it can have a 4. We'll find out. Okay. High-low game with handled input going for an hour and a half, and then I'll keep going. Hopefully I can get this done pretty quick. Well, okay, we'll see. Okay. So what do we need? We need high-low. The game needs random in order to get a random number for each time the program is started. So we need a random number for the program. We need some other stuff. Put an output and stuff. So we need first we need to get a guess. So I'll just do a header file for and an implementation file for rip something off the case that was loose. Okay. Say high-low game. If find high-low game H, find high-low game H, and if got our little header guard going. Namespace. Excuse me. We'll do namespace. Get input, and then we'll have another namespace for high-low. And we could say void the game. That's one function. We could pass it in guesses, the amount of guesses we want. I think guesses. I'll just say guesses remaining. Or max guesses. We could say max guesses. Okay. Get input. We just need a way to get an integer. We need a way to get a character too. So we'll just do that like normal. And get in. Oops. All right. We'll forward declaration. Character. Get character. What else are we gonna need? We're gonna need some random stuff too. So high-low will have to get a random number, and then we can do that too at some point. So we could say, maybe it's good to split this up. So we could do high-low. This is all for one thing. One purpose, maybe we do it all here. So there's get input, but we just split it with namespaces. Getting input, namespace, random nums. Okay. We could do, this is going to need random. This is going to need character input and output. So we'll need chrono for the random number generator to get steady clock. we need, in order to seed a seed sequence, in order to seed our Mersenne twister, we need input and output. All right, so we need steady clock, or rather standard chrono steady clock for to seed Mersenne twister. Need standard character input and standard character output because, of course, random. Need standard Mersenne twister. Need standard seed sequence. In order to seed it, we need random device as another way to get random numbers from the operating system. So we need to get input, we need random stuff, and then I think that might be all we need. Good. You can hear the dogs too. That's fun. Okay. Okay. I won't fuck with the random stuff just yet. Okay. Now we'll do an implementation file. We'll just call it high-low. Oops. High-low game. Include high-low game to resolve any type discrepancies between type mismatches between the header file and the implementation file. Okay. Definitions aren't found, and that's all. Cool. Okay. In order to get an integer, we're not going to prompt the user because the prompt will come in the game, which is fine. Just getting an integer from the user, easy peasy. We'll do user integer, value initialized to 0, standard character input extracted to the user integer, and then we'll return the user integer. But we're going to need some other stuff in order to clear it up. So we'll have another, and we'll just call it avoid ignore line. Matters if I do it here or not. Okay. And ignore line is simply ignoring a certain amount of characters up until the character we want to stop ignoring. In that case, it's the end line character. We want to ignore everything. We also need numeric limits in order to ignore everything. So we need limits. So we need to standard character. What was it? It's standard character input ignore, and we're ignoring until an inline character. What are we ignoring? Oops, did that wrong. Should have just done a parentheses because it automatically puts the closing one. And we'll ignore standard numeric. Standard numeric limits. We're going to ignore something about the stream size, standard stream size, and we're going to ignore, we're going to ignore the max. So a numeric limit max, what is the type that we're passing in to get a max of? It's a stream size. Cool. So here, do a few things. Handle, or actually, we should do a, we should do a do while loop here. So that we get input at least once, and then while the input, let me see. trying to remember the while condition. I think we're just going to say do while, and then we return early. And if input is wrong, yeah. So if input is wrong, then the loop just executes again. But the while loop again, what is the condition? Oh, duh, it's just while true. It's an infinite loop. Okay, I'm stupid. All right. Oops. Oh yeah, so we don't even need it to be a do while loop. We'll just say while true. It automatically executes anyways. Oops, while true. And then we'll do all this. And then we'll say go to extract. Not going to return yet. So we'll extract. And then we'll say we'll continue in some spots, and we'll break in other spots, I think. Oh no, instead of breaking, we'll just return. Okay. So at some point, we'll return. But for now, let's handle invalid input and EOF characters. So we'll say if not standard character input. This means input extraction failed. What we're going to do is check if standard character input dot EOF, the EOF member function, the end of file member function. If we see this, it means the end of file character has been entered, which means we want to terminate the program. Why? Because if a user enters the EOF characters, it means they want to terminate the program. Or it means, like in the case of reading a file, we've reached the end, which means we want to stop reading. In this case, the character means that we should end. Movie's at 10. I think I'll just go for 3 hours then. So maybe no break. So I'll do a test at 8 o'clock. I do the test. Hold on. How long have we been doing? 20 minutes almost. So it's 8, 10. So 30-minute break at 6:30. Okay. Or I'm sorry, at 8. Oops. Okay. And then test at 8:30. Okay. Trying to stay to a pretty strict schedule. And then done at 10. Cool. Schedule's done. Okay. Send a text again. Okay. Sorry. So this means UF character entered, terminate program, which means we want to do standard exit. We'll have an EOF character, get input, and we'll just say constant Can't be const expression. Actually, it could. Yeah, it can. Seven. EOF error. Cool. Okie doke. If it didn't, okay. If we overflow, input failed. But if we have a type mismatch, we try and extract an integer into a character, etc., vice versa, then it also fails. So we need to standard character input clear. Remove failure flag from input buffer, or rather, remove input buffer failure flag, and then ignore clear invalid input buffer. Rather, this should be removed to make sense. If it failed, we'll do this. Excuse me. A few things here. One, let's handle this case. UF character entered, terminating program code. UF error. Cool. And then here, if that, then it ends the program. Otherwise, invalid input, type mismatch, or we'll just say invalid input. Retry. Okay, that's if it failed. If it didn't fail, and it's only extra, then we'll do standard ignore, or sorry. Input extraction didn't succeeded, but has extraneous, includes some extraneous character. If standard character input p is not the inline character, if it is the inline character with the end, if it is not, then there's extra stuff. So we'll say, what is happening here? Extraneous input detected. Removing it. And then we'll say ignore line. So extract input. This happened, cool. And if input was invalid here, then we'll say continue. Want to clear, or to re-clear input. Want to re-clear input buffer. Discard I think go next loop makes sense. Go next loop. Or just continue with it. Okay, so we've extracted, we've handled that, we've handled extraneous input, and then finally, this is correct, this is an error, this is simply clearing. And then at the very end, because this continues to get us out, so these are invalid cases we need to redo, so we continue. These, outside of that, are valid cases, maybe with extra, which we remove. Then at the end, we return these are in. Excuse me. We could actually do the same thing with this here as the character. Yeah. It's kind of redundant. A template might be better at this point. So like if it's an integer, do this. If it's a character, do this. But since they're different types, I think this is the only way. So we'll do get character. Now instead we can say character, user character, user character. Within user character. User integer. Handle input. User character. Handle invalid input. Null one. Empty the input buffer. Or clear input buffer until \n, which is the underlying character. You can do some random number stuff. You can do high-low, play game. We would do that now. Oh, press backspace. I guess I was wrong. Okay. So we'll say prompt the user to start the game. My number is something, some number. So we need a random number. So we'll say constant target number, initialize some random number generator. Is target number. Oh wait. And play game should be called with max number of guesses, and it should have a minimum and a maximum, I guess. So we could say from this to this, min range and max range. Okay. Number is between min range and max range. You have max guesses. What the fuck? Guess it. and we could do this, and we could say, this would say 5 guesses between 1 and 100. Oh, whoops. The unique functions. It's seeing that it's not used elsewhere, so it thinks it can be made static, but it can't. Oops. What was the error? Target number? Oh, true. Okie doke. So we'll get the number, and we just have to initialize this guy properly. And we have a do while loop. Or we could have a while true. And we could have int guesses outside here. Because if we had a for loop, it would be... Well, we could have that too. Yeah, we could do that, I think. For... int current guess. Yeah. From 1, while current guesses is less than or equal to max guesses. So 5 or whatever. Oops, didn't do a semicolon, that's great. Oh, sorry, didn't even put the parameter. Or, I don't even know. Current guess, while current guess isn't greater than max guesses. Okay, and then we'll say we'll increment current guess. Okay, and then we'll do some stuff. So we'll say guess number current guess. That. And then we could track the guess here. So that's current guess, or oh, this should just be guess number. Guess number. Guess number. Guess number. And current guess should be whatever. 0. And then we can say, because each time we're not changing current guess, so we can say here, we'll say current guess is get input, or oops, get input, forgot the namespace, get int. So we'll get current guess, and then we'll say if current guess is target number and say correct, you win. Okay, and then break, or actually in this case we return, no, we break, and then we could set something to like did win bool here, and then be set bool player win, or did player win. So you win, and then say did player win is now true. And then we could say and then let's just say, okay, you won. We'll say that. And then, so it's if it's the target number. If it isn't, we could do something else. Or, since we're actually breaking here, it's fine. I think we could just put the code here. Or I could do an else. But then, if this break gets removed, I'm going to do this. It's just a little redundancy, but it's okay, I think. Incorrect. Guess again. Okay. And then, okay. And then it loops, and then says guess number whatever, and then we go. Okay. And then at the end, we say if did player win we say if there's the win message. This is only an incorrect message, but then we need the lose message. If did not did player win, if player did not win, we say you have exhausted, or say out of attempts. My number was target number. And then another right here, and we'll just say I think we end that. If you win, and it breaks, this doesn't execute, and then you're good. But if this is win, but otherwise win is false. And I could set it to be false, but it's already technically false. Just to make it sure if it gets default initialized to something else somehow. I lost. Or actually, no. So this isn't needed. So it's win. It's only set to be true if the player wins. Otherwise, it stays false and the player didn't win. Okay. Then we could have another function to get the attempt to play the game. This could all be nested again, but it seems kind of crazy. This isn't needed. Flatten that. So it's simply a game. There's one for loop, and it has if statements in it. So it's 3 levels deep. 1, 2, 3. And I could have a do while and have it all within there. Okay. We could start it to be. We Could say do, and then while player wants to play the game, do. What would that look like? See if I make a mistake here. Do this. So, why is that? Oh, okay. This is in play game. Gotcha. So do. Oh wait, no. Hold on. Within play game. What is this? Oh, I think it was just in the wrong spot. In the game, we do all of this while character play again. This should actually be a bool. This should be bool play again. And it is if this should be get input, get character. Oops, and that's the location of get character in memory. If this is assigned to be this whole guy. Oops, what are we doing here? Oh, okay. This whole thing is assigned to be is get input true. Or is get character true. It's a semicolon. Oh, whoops. This should be we could say do this while something. We have to initialize that thing before. Or we could say while true. We could say that. We could say while true, do all of this. But then say instead we could say yeah, we'll get a bool here. Bool. Now we could say play again. And then we could say if, and then call that function, or just have a boolean to save it. I think we could say, I want to say if, and then that, I want to save that, because maybe we use it. So we say bool, play again, or bool should play again. And it's assigned to be get input, get input, get character, if that is true. If that is yes. This is actually correct. Okay, yeah, we should be. This is just the wrong way of doing it. That's just not it. We need to just get the fucking character one time and then do comparisons on it instead of if, call it to get something and then get it again. That's not right. We only want to get one input. Should we play again? Character should play again. and it's just get input, get character from if should play again is not yes, and should play again is not yes, then return. This should be like that. Character should play again. Oh, we don't even have the higher or lower thing, but I can put that in. We get should play again, and then if should play again is this. If it's not this and it's not this, then we return. So if it's anything but yes, we return. Okay. Okay. All right, we'll say this. If it's correct, we say this. Otherwise, we say this. Yeah, this is actually good. Say incorrect. And then, is it higher or lower? We say incorrect, yes. Incorrect. If current guess if it's equal, we've already broke. If it's not equal, we can say if current guess is greater than target number, already has the space, guess lower, or incorrect, lower. My number is lower. Else, we could say handled properly. if it's equals, it's already handled. So could we just do else in this case? What would be the right way? Or we could say, I think we say is what if we say number is 15? And we play. And then whatever, it's supposed to be a random number. Let's say it's 15. 93. Oops. The number is lower. Number is higher. Oops. 14 is higher. 16 is lower. Huge, huge, huge number. Huge, huge, huge number. Huge, huge, huge. 1 and 2 is 1, 2, fail, 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 fail. 3. Oh, we've guessed once, twice. Three times. Or we could pass it the current guess. This is looping in here. Could pass it in here. And guess number. Maybe not. Maybe we just leave it. Leave it like that. 14, 16, 2, 3, 4. Out of attempts. The number was 15. Is that? One, two, three, four, 5. No. Done. 1, 2, 3, 4, 5. Yes. 14, 16. Cool. 15. You win. Yes. 15. Yes. No. Okay. Okay. Now random numbers. So, excuse me. We can. How did we do it? I did it yesterday, day before yesterday. I didn't do programming yesterday. I did. Well, actually, I did a little bit on the plane, but not as much as I should have. I got home and we were talking and stuff, so there was no time. So, if we have a static Mersenne twister, or we just have a static one that's created at compile time and seeded, And then, yeah, it's just seeded once. And then we don't call that again. That's only called once. Okay, so there's a Mersenne twister that's created when the program starts, and is on program start, initialized value. Cool. And then, because that's when global variables are created, on program start, they have static duration. Cool. And then, later on, we just call calls to it. Okay, so we have a static standard Mersenne twister, and it's called our number maker. And then we can have number generator, pseudo, or we could just say it's a pseudo random number generator. Okie doke. And then we can have a standard Mersenne twister returning function called seed Mersenne twister. And what it does is it creates a random device to get some of the seeds. It's easy random. Or we could just say random device is fine probably. Okay, we just create that guy. And then we'll seed a seeder, standard seed sequence, empty seeder. Oops, where did we go? And it is seeded with, what did I do yesterday that was wrong? Steady clock. Max. Did I just restart it? I might have. So we need to get a number, an integer, that is random. 7 of these will be generated from the operating system as just easy randomish numbers. And one of them will be based on time. So that to get the same stuff should be hard. So we're going to do a static cast to the return type of a Mersenne twister, so we can pass it to a Mersenne twister. What is the value that we are doing? It is standard chrono steady clock. And it's now time, the time since the last time that was measured. And oh, I was doing max, maximum time, which is not the correct answer. It is the count. It's the seconds that have passed. And really, I could probably just do shift end and then, oops, well, maybe you fuck it all up by doing that. Maybe I can just close this. And so, first seed is that, and the next are all rand device, and device, and device, 3, and device, 4, device, 5, and device. 6 and device. 7. Oh, it's already been an hour? Oh shit. It's taking a while. Sad. Okay. See it in this? We're not returning anything yet. That's the issue here. Must be an old issue. Uh-oh. Where? Finally getting 89? What are you yapping about? That whole thing. Oh. What's happening here? Same seed sequence. What? Oh. We'll return a Mersenne twister as initialized with nope. We're going to do the value of the Mersenne twister we want. We'll just say no, we don't need a uniform distribution. Yes, we do. No, we get numbers. Okay. In this case, we're just going to return the Mersenne twister that's been seeded like this. That has been seeded with empty seeder. What's wrong here? Oh. So that's cool, but this wasn't? Oh, that was why. We were just somehow converting this value to a Mersenne twister instead of converting it to the result type of a Mersenne twister. Because this is, seeder needs to be numbers that can go into a Mersenne twister. And the Mersenne twister comes out with a number. Oh, hold on. Mersenne twister result type? Does this mean the result type that we're getting to, I think this is result type, the type of a result of a Mersenne twister, which seems like it's an unsigned int, so we're passing it unsigned ints, having some deja vu here. Cool. So we have Mersenne twister, and we have this guy, which is seeded with seed nt. Big deja vu, holy. We could have yesterday and the day before making this. And then we'll have int get random int, the function. And what it is, it has a standard uniform int distribution called num in range. This takes two parameters. This guy doesn't exist yet, there's no declaration, but it's okay. Oh, it is needed though. And we actually don't even need some of the random number stuff here. So this has int min range, max range, max range. Target number is assigned, min range, max range. Okay, cool. So we can say this takes int min range, int max range. The range is min range to max range. And or we don't actually need to create that. Could we just return number maker oh wait, no, because we return the number maker passes the value to the uniform int distribution. So we could return. No, because we actually need to call the uniform. Oh wait, no, yeah, we can though. Because we can do initialize it and call it. Could I have done this up here? I guess we'll do it here. Return uniform int distribution initialized to min range, max range. Excuse me. And he is called to take number maker. This. What? Oh, whoops. Standard. We are returning the value from number maker in this range. That was the old compiler error. Returns number in range in given range from the Mersenne twister. This is random nums get random int. What is the issue here? Oh, we have not passed it the range. Min range, max range. That's why the error was under the parentheses and not the identifier. Oh, that's cool. It just shows you the next line. Yeah, that's nice. Okay. See if the game is playable. Oh, between 1 and 100. And we pass it between 1 and 100. And it gets a number between 1 and 100. Cool. Good. We'll say 45, 70, 63, 65, 66, 7, 8, 9. 6, 7, 8, 9. It's gotta be 8. Fuck. Damn, 6. No. Huge, huge number. Huge, huge, huge number. Okay, 3. It didn't fuck up a guess. Cool. A, invalid guess. A with valid input. Input with invalid input after. So it removed the extra input and said incorrect numbers higher. 34. 68. Oh my god. 94. 71. Yes. Cool. Yes. Nice. Anything else? Handle invalid input. Oh yeah, true. It needs to be out of range. So there's valid and invalid integer stuff, but there needs to be valid and invalid guesses. Guess out of range. So we could say And so this is after a valid guess has been acquired. After valid guess. Or handle or evaluate valid guess. Okay. And we could say do all of this while guess is invalid. So while current guess is less than min range. Oh, all that. Or current guess is greater than max range. We'll do that. And then if current guess is greater than min range, or current guess is greater than max range. Oops, why did I do that? No. What the fuck was that? Oh, you can just tab it to be true? Oh. If that, say, guess out of range. Guess out of range, retry. Okay. Cool. We say 1 and 100. 1 to 1 is out of range. 0 is out of range. -4 is out of range. Huge number is out of range. Huge number is invalid because it's too fucking big. Just like this is invalid. We're clearing the invalid input, so we are resetting standard character input, and we are removing the invalid input so we can actually put in a valid guess, and then it's treated. Oh. Cool. Oh. And then we could have a test. Can I write code to test some different values once it has been guessed? It seems like when you do this, you wouldn't necessarily write a whole thing and then call just that function to test it. It's almost too modular. You would just call the function the game, and you would just call it with a series of test values. So you would do a little you would maybe call a function to do this one, and then the next you have like a static number inside another function, and you call it with 1, 2, 3, 4, 5, and then it loops again, and then you call it again, and then it keeps on calling with those same values, and then whatever. And maybe you call it, maybe you have a function that calls the game 5 times, or you do it, and then it passes it yes a bunch, and then once the count has happened enough, it's cool. It seems good. Okay. I think that's alright. See if there's any way to improve these things. Getting input, checking if it's valid. In this case, extraction failed. We either need to kill the program or just clear and reset. If there's extraneous but it was valid, just ignore the line. Same with a character. Let's try that real quick. No, and then huge ass thing. Extraneous, and it's no because it extracted the W. So you can't overflow a character, seems like. And I guess you could just pass a big number and then static cast it to a character. And it would just loop until it finally lands on wherever it needs to be, minus all the overflow extras. We have a static Mersenne twister. High-low is included. But we don't need anybody else to get access to the random numbers. We don't even need anybody to get access to the fucking... Well... Yeah, this guy could just be in here. These could all just be static. But probably not, because we could eventually call this guy. But we're not, because this is for the game, so fuck it. Static. 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 Not static. Otherwise, linker can't see this. Could just do a go-to. Could do this. I'll put something in break now. I'd rather handle these individually. That way we don't have to redo. We don't have to have two different thanks for playing. It's like if you lost, do this, then say thanks for playing. If you did this, if you won, do this, then say thanks for playing. How about if you won, do this. If you lost, do this, and then at the end say thanks for playing. Actually, yeah, because this breaks and then triggers here. So regardless of if you won or not, it's this. So winning or losing only determines whether or not we output out of attempts. Invalid guesses. Valid guesses. 43x. Yo, what's happening here? What you mean not found, yo? Oh, because if they're static, the order does matter. So this needs to be before. Because when we include the header file has the prototype, so it's like I'm prototyping in the same function. So maybe it actually does make sense to keep them there. But I want them to be static so that shit that doesn't need them doesn't see them. Noted. That's cool. Alright, so we can say 43x. Yeah. So it took 43 and then said fuck the x. Input failed, reset input, and then boom. Extra. See what you did. How long did it take you to do it? Are you shitting me? You did it in 87 lines of code? Oh my god. You didn't even do chrono. You have a get gas. Oh, and then you don't have a function for getting characters. You just get characters. You don't even have a default? What happens? Oh, it's Walter, so it just keeps happening. And it just says, would you like to play again over and over again? You could do a switch. Yeah, I don't like that way. Oh. Are you tripping? Oh. This is shit. You fucking while loop calling that again? No, just have one thing that's reusable. That's weird. What in the fuck? Bro, what in the fuck? Oh, so you can paste it all in one file. Okay. Type conversion now, baby. Yep, there's type. Oh, yeah, this is implicit. Why? Just to do things in maybe an easier way? I don't know. Instead of having to do a static cast? Or maybe it's just understanding how things implicitly get converted? Ah, balls are itching. Formed automatically? Mm-hmm. Yep. Uses it as input, and then yeah. So converter is like a function. Which is probably why it looks like that in Unreal Engine, where it goes from like green to red or green to pink if you're giving in int and or a float and taking out a string. Oh my, that scared me. Well, all right, break time. Break time, yo.